Scientists have been hunting it for 40 years. The key that will unlock the secrets of the universe. And now, they've found it. Can the Higgs boson really tell us how all creation came into being? Do we owe our existence to something so elusive, yet so powerful? Is there a God particle? Space, time, life itself. The secrets of the cosmos lie through the wormhole. How did we get to be here, in this universe? Scientists say our universe began as a burst of pure energy, but somehow that energy transformed itself into matter, which eventually became stars, planets, and the stuff that makes up you and me. Instead of being a fleeting fireball gone in an instant, our universe has stuck around for billions of years. Physicists have long suspected there must be some invisible force field spread across the universe, mysteriously turning energy into solid matter. Now, scientists have at last proven that this theoretical force field is real. They have produced from it a subatomic particle known as the Higgs boson, the so-called God particle. Can it explain the mystery of our creation? Have you ever watched a spinning top? As a kid, I remember being mesmerized watching the painted shapes spinning on mine. The pattern became a ghostly blur. Looked like I could stick my finger right through it. But once it stopped moving, the pattern became solid again. The solid nature of matter has long puzzled physicists. Over the last 4 decades, they have wondered if matter is solid because of the Higgs boson, the so-called God particle.
You know what they really wanted to call it, right? They wanted to call it the God particle.
You probably can't put that on TV, though.
Given the amount of time and money we've spent looking for this thing, and we've missed it. Oh, damn, where is that particle?
Dan Hooper and Patrick Fox are theoretical physicists at the Fermi National Accelerator Laboratory just outside of Chicago. Like thousands of physicists, they have spent their careers waiting for the Higgs boson to reveal itself in high-speed particle collision experiments. In fact, that there was a brief moment when the universe lived without the God particle. It was at the beginning of time itself, long before there were physicists and arcades. Imagine this air hockey table is the entire universe. When it was born in the Big Bang, physicists think there were only massless particles of pure energy.
So what you can see here is that all the particles are moving around at the same speed, at the speed of light. They're all essentially massless in the early universe.
But the universe did not remain that way for very long. After only a fraction of a second, something changed. Almost like someone pulled a lever that made many of the particles grind to a halt.
At some point, the Higgs field turned on, and that made some of the particles acquire a mass, which meant they stopped traveling at the speed of light. The photons, the yellow ones, are zipping around at the speed of light, whereas the red and the green have acquired a mass thanks to the Higgs mechanism and travel more slowly.
Physicists believe that right after the Big Bang, the universe began to cool and the Higgs field turned on. Some particles began to interact with the field and acquired mass. Other particles remained massless bundles of energy. In the decades for which scientists have been smashing together particles to probe the subatomic world, they have found 2 basic types of particles. There are fermions, a group of massive particles that carry matter, and there are bosons, massless particles that carry force. Without the existence of the Higgs, all particles would be massless.
So if there was no Higgs field, you would have had these other force carriers. They would have been massless, and therefore, like the particles of light, they would move at the speed of light.
And without these masses, you could never have atoms or chemistry or any of the interesting stuff we find in our universe.
The things that you and I are made up of wouldn't be able to clump and coalesce and slow down.
No structure, no life,
Right.
boredom.
Yep.
Thanks to the Higgs, our universe hung around long enough for complex structure like human life to form. But why did the matter of the Big Bang jostled the field into action?
So up until now, I've been turning the Higgs mechanism on and off by hand. But of course, in the early universe, it didn't happen that way.
And just like water freezes all on its own when you cool it, the Higgs mechanism will turn on all by itself as the universe cools.
So this pool cue is supposed to represent how unstable the Higgs mechanism was all by itself. And as you can see, it just falls over.
Scientists think the Higgs field, the force that turned a ball of energy into our physical universe, turned on all by itself. But some will say that it was no accident, and it must have been turned on by a creator. That mystery of creation may be answered if we learn more about the Higgs field. Scientists have been trying to disturb the field enough to make it produce a Higgs boson so they can study it. It's an effort that has made physicists construct the most powerful machine in the history of science, the Large Hadron Collider, or the LHC. Lynn Evans has been responsible for building every particle accelerator at CERN in Geneva for the past 4 decades. All the machines he created are still working. In fact, they all work together in stages. Each older one is now responsible for giving the particles an incremental push, packing them with more and more energy, and eventually feeding them into the giant 17-mile-long ring that is the LHC.
I came to CERN in 1969. My first job was working on what is called the duoplasmatron ion source, which is actually the source of the protons, and then they are accelerated. From the linear accelerator, they go into a booster to get higher energy, and then into the super proton synchrotron, which I worked on in the 70s, and finally into the Large Hadron Collider.
As particle accelerators have advanced over the past few decades, they have been able to get particles to higher and higher energies, allowing them to create more and more massive new particles with each collision. The older accelerators only had enough energy to smash together 2 protons and make a new particle with just double the mass. But theorists predict the Higgs weighs at least 100 times as much as a proton. The laws of physics say that if you give protons extra kinetic energy, you can smash them together to form a new particle that weighs many times more than the sum of their parts.
Well, it all goes back to the most famous equation in science, E equals mc squared. In the LHC, we are converting energy into mass. And if you want to make very heavy objects, you need a high energy.
Think of particle physicists as golfers hitting protons instead of golf balls. Over the years, they have gotten better and better clubs.
To make an analogy, I think this pitching wedge you can think of as the machines of the 60s. This will take me about roughly 120 yards, something like that, because it doesn't have enough energy to go very far. Then the next one was the proton-antiproton collider. The proton-antiproton collider was much more powerful, and yeah, a bit like a 7-iron. This time the particles will get more energy, and will go quite a bit further. And finally, of course, now we've got at last we've got a machine that can produce the Higgs boson. And if you want an